and that data comes in, and I've zoomed out a bit. This chap has just been driving around the Democratic Republic of the Congo, and their data is just in this region, and it's automatically shaded according to the prevalence. So if everyone in the village had the eyeworm, the dots would be bright red. Where no one's got it, it's bright green. So this area is really quite clear, apart from perhaps a slight trend towards the south, slightly higher prevalence there. So they've got that. What they want to do now is, let's scenario. Suppose they want to go and treat Geomatics in this region, up here. So they need to know now, using the data that's in the system plus this additional new survey, what's going to be the prevalence up there. So from the menu again, totally menu driven, exceedance prediction. You say what survey layer you're going to use, and you can draw a rectangle for the area where you want to do the prediction. You can set the output resolution of the grid, where you want to store the output, and add a little note that goes into the output directory. And once you click OK on that, R does its magic, reads all the data, and produces a new map layer. You can see here in Quantum.js, standard map layer, it's a raster layer, and it's coloured nicely. So red is the region where we know that the prevalence is above 20% with a 95% confidence. Blue is the region where we know the prevalence is below 20% with 95% confidence. And grey is our grey area, which is where this chap should now drive his Land Rover, and then he could, if he collects some more data here, we could eventually, this map, make it just red or just blue, so we can be sure it's above or sure it's below. The more data we get, the less of that grey area we get. And this system tells them where to go to collect data for the to figure out, you know, where this grey area is. So that's a desktop application. Did this a few years ago. It was I developed it on Linux. It was used on Windows. I developed an installer on Windows that was an open source installer package. And because it was all open source, we could just ship the whole lot out to them without them having to worry about licenses. Okay, that's all right. Amensis is a new project that we're working on now. We've just got a grant from the MRC to look into meningitis reporting. And the idea is we'll get weekly meningitis counts for small areas via the World Health Organization, and they want to be able to predict epidemics. Okay, here's a map of Niger. Again, this is a screen grab from QGIS with my adjacency colouring in again. And all the way across Niger, these regions of Niger, these health areas, the counts of meningitis cases are very spiky. This is about 10 years of data. And you can see there's the spikes that occasionally go very high, sometimes they're quite small. They don't occur everywhere. Some places seem immune, other places get them regularly. We don't really know. You can map them, you can plot them like that and look at the patterns and try and get some insights into how, whether adjacent regions are spreading the infection to each other, or whether it's occurring in the deserts or in the rural areas. You can do all kinds of exploratory analysis and come up with some statistical models. Okay, press button 1 if you think you could implement a dynamic linear regression from my equations. Hey! One man. Okay, so again, lots of complicated statistics that we want to hide from the users. What they really want to know is, given their data, which is the black circles, what does our prediction say is going to happen? Now, being statistics, we can be uncertain. We don't lie with statistics. Anyone who tells you the truth in statistics is lying, because we can never be sure. So our prediction, solid grey line, is always going to have an uncertainty. Okay? And if they're interested in whether that prediction is going to go above this red epidemic threshold, which is currently where they go and roll out vaccines. We have to tell them that we're 95% sure, we're 5% sure it's going to go over the threshold. So there's always an uncertainty. So maps and things, well, it's going to be it's a bit complicated to give people numbers with standard errors on them. What they really want is an alert. Okay, so they tell us the criteria for the alert, and then we tell them. And my boss, Professor Diggle, has been out to Niger and to Ouagadougou and Burkina Faso, to Ethiopia, and they don't really have much in the way of internet connectivity. Everyone has a mobile phone. So hopefully, when we get this system running, we'll be sending out alerts via text messages, but we'll also make that available as, say, a news feed or as emails to the guys out there and to the health ministries. But what I did, just as a kind of technology demonstrator for them, is to develop what a website would look like, where they could go and get the information, perhaps once they've been alerted to it via a text message. Now I think the rest of this talk could just demo live. I'm feeling daring. Okay, so this is a this is a demonstration website. It's got purely synthetic data on it. Full screen. Oh, there we go. Okay. So they'd get an alert, they could come to this web page, and then they can kind of drill down. The latest alert messages will be listed over here. So, epidemic predicted in Agadez. Click here, and you get a summary. Obviously, it's in the future. The rate is predicted to rise from 7.6 to 10.2. The probability of exceeding the epidemic threshold is 0.52. So that's saying it's a 50% chance it's going to go above 10. Now, there's a map. This is an open layers map, and superimposed on that are our prediction data. The red dots are regions where we predict that region may go into an epidemic above this epidemic threshold. The yellow ones are regions that are currently in an epidemic state, and the grey ones are wherever we've actually got any counts at all. So you can just click about that and see what you got. And if you click on the region code, you can get a plot. Now the plot is done using an open source plotting package, a JavaScript plotting package. And you can zoom out. This year, that's the first case they've had this year. It's happened for the whole 2 years we've been running. They haven't had anything, and then suddenly we predict it's going to go to an epidemic. So they might, the responders might decide we have to prioritise this region because there's no immunity in there at all. We'll go and treat it with a vaccine. And we can get the information for any of these regions. We can look at the time series. In this case, we're predicting under the threshold, so everything's green. Let's zoom out, take a look. Well, they had a little outbreak back in April 2010. Nothing much else going on. So you can kind of explore the data temporally from there, or you can go back to the map and explore the data spatially for now. There's also a kind of simple report page like that, just summarising what the current status is, that could be printed off and taken to weekly meetings. We can make that available as a PDF, perhaps. We can even look at the cases where our prediction is 0, nothing's going to happen. That was a very nice place to live. There's no meningitis there. And the other thing I did as a demonstrator is Space-Time Data Explorer. Now, this is built with open layers maps and the float charting JavaScript. And as soon as I click on a region here, you see the time series of meningitis cases for that region over there. And I can click on multiple regions over here, and I see the time series for those regions. And they're labelled as well. This is all automatically done with this plotting one. So now I'm getting an idea that maybe these regions in this middle belt here seem to have outbreaks at the same time. This is, I'm getting new insights on my data from a fairly simple tool. Whether they want to use this or not, we don't know. This took me a couple of days to write, just to link the existing maps with the charts that I had. Pretty simple for a sort of a mapping JavaScript geek like myself. So there you go. We're hoping to plug this into the real statistical methodology sometime later this year. We'll get the data on stream later this year, once we can clear things with the government or lack of government in Niger at the moment. It's all fairly unstable. We're also rolling this out for Ethiopia and probably Burkina Faso as well. Getting the data is the big problem. We hope to be able to do something nice with these things. So that saves me having to go through my static slides. Much nicer. So I just want to roll the end credits. You've heard a lot of these things mentioned already today. R in particular is new here as the statistics open source system. Flot is the charting package. I've discovered another new one called ProtoVis, which does incredible charts and plots and graphs and pie charts and 3D things and visualization. If you need any kind of data visualization, ProtoVis just looks amazing to do it. The web development backend is going to be done with a thing called Django, which is a web framework, open source web framework written in Python for producing dynamic web pages. I've used that a lot for various projects. But the core of this has been PostGIS, QuantumGIS, OpenLayers, the thread that's run through a lot of the things today. So that's one aspect of the credits. The real aspect of the credits is the project contributors, the sponsors of the open source tools, and the open source community themselves, which includes me, because I've contributed code to R and to QuantumGIS and the various other things. And it's very easy to get into that crowd. This scene here, there are no bouncers on this club. You can just walk in and take part in the open source gig as a performer. So that's what I've been doing. Any questions?
I just asked a question. I noticed that earlier on, do these QuantumGIS have a name as well as a version number? You said something called MyMass or something.
Yeah. They started naming them after planets or moons. 1.3 was Tethys and 1.6 was, I don't know, moons of Saturn or moons of Jupiter. But then the company got a bit unhappy. Another company that used MyMass or Tethys